Hello.
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 Hi. Good morning.
Today, our focus is we did proportional relationships and then we did non-proportional relationships. So today we're going to look at telling the difference. What is the difference between a proportional relationship and a non-proportional relationship? What's the primary difference? What's the one thing?
Proportional, they all go by a certain number. Non-proportional, do not.
It's close, but let's...
The rate.
It stays the same.
Well, let's think about the two equations. So we have two equations, right? We have y equals kx. Do you remember that one?
Yes.
And what kind of relationship is that? Proportional. And we have y equals mx plus b. What kind of relationship is that? Non-proportional. What is the difference in those two equations?
That an L or T?
One of them's
M and the
off
X.
the line.
Huh?
One of them doesn't start on 0.
Right. In y equals kx, k and m are really the same thing, just different things. In this one, it really does have a b, but b is 0, isn't it? Because it goes through the origin. So a proportional relationship goes through the origin. A non-proportional relationship crosses the y-axis somewhere else. Does that make sense? Proportional relationship always goes through the origin. So when you look at it, if it goes through 0, 0, where x is 0 and y is 0, then it's proportional. Correct?
Yep.
So let's look at a couple of graphs. Graphs are my favorite when they ask you. Look at this first one. Does it go through the origin?
No.
So what kind of line is it?
Non-proportional.
This one's non-proportional. Does number 2 go through the origin?
Yes.
Yes.
What does that make it?
Proportional.
Proportional. And really, when you look at the equations, number 1 use the equation y equals mx plus b, right? And number 2 use the equation y equals kx. So that's what we're looking. If it's non-proportional, it's y equals mx plus b. If it's proportional, it's y equals kx. So let's look down here to a situation. So we've got 4 equations, right?
Yes.
Now, let's look at this first one. D equals 65t. Now they have changed y and x, haven't they? Can I call y and x some other variables?
Yes.
Is it legal? Yes. So what kind of equation is this?
Proportional.
Why?
It doesn't have the plus b.
Because it follows the format of y equals kx, doesn't it?
Yes.
It's proportional. The second one says P equals 0.1 S plus 2,000. Why?
It's because it has, you have to add it.
What formula is it following? Is it following y equals kx or y equals mx plus b?
Y equals mx plus b.
Yeah, because right now it's got y equals m, which is 0.1 x, they call this s, plus 2,000, which is our b. So this is a y equals mx plus b, which makes it non-proportional. Let's look at the third one there. N equals 450 minus 3p.
Non-proportional.
Why do you say it's non-proportional?
Is that you add
Well, which format does it follow?
y equals mx plus b.
But they did something funky, didn't they?
They added a variable to be another.
They just moved things around. Think about this equation. This equation is the same as N equals negative 3p plus 450, isn't it?
Yes.
It's just written backwards. It's written like you wouldn't want it to be written. So their goal was to trick you by writing it in another format. But it doesn't change it. It's still y equals mx plus b, right?
Yes.
So that one's non-proportional. if I can spell non-proportional. Last one says y equals x3. Why do you say proportional, Elliot? But it's still got x first.
It doesn't matter, they're still being multiplied.
It's just written poorly, right?
Yep.
Because it really would be y equals 3x, wouldn't it?
Yes.
So it's proportional. Get in the habit, if you see something written incorrectly, get in the habit of fixing it. Get in the habit of writing which equation is involved in the question. Because now we're going to kind of start mixing our equations, right? Get in the habit of, if it's a y equals kx, stick it right there by the equation. If it's a y equals mx plus b, stick it there. If you do that, then you will see it. Does that make more sense? And you'll see it faster and faster and faster until the point where your mind actually just sticks it right there anyway. Okay, so let's look at tables. So I got a couple tables. How do I know if they're proportional or non-proportional?
If they all add up to the same.
What's the key between proportional and non-proportional? What does proportional do that non-proportional doesn't?
It stays at a certain rate.
They all stay at a rate. That's the slope, right? What's the one thing that proportional does that non-proportional doesn't? It goes to the origin.
It kills the Wookiees.
It kills the Wookiees at the origin. So, one, I'm going to check and see if they're definitely, and this comes to future, if they're definitely following a rate. So what's the difference between 2 and 8?
6.
How about 8 and 14?
6.
Okay, 30 and 90?
60.
90 and 150?
60.
So I put y over x. So k equals, or m equals y over x, right? The difference in y over the difference in x. And that equals, what's the difference in y in one of these? It's 60, right?
Mm-hmm.
And the difference in x is 6.
Mm-hmm.
What does that simplify to? 10. Now that I know, I can actually follow the pattern going backwards, right? If I go back from 2, remember, when I'm looking for y-intercept, what is the coordinates for the y-intercept? What does b equal? 0, comma, b, right? Whatever b happens to be. But it's always 0. So if I can get x to 0, then I know the b, right? Mm-hmm. Well, how far from 2 to 0? I'm going to put my 0 up here. How far from 2 to 0? 2, right? So same thing here. We know that it's 10, right? The rate is 10. So what over 2 is 10?
5.
What over 2? Think about this. 10 over 1 equals x over 2.
It's 20.
So what did I multiply 1 by to get 2? I multiply by 2. Do the same thing up here. What's 10 times 2? So here, if I ran these all the way back to where x was 0, I got 0, comma 20. I blew it there. 0, comma 20, right? Is that at the origin? So what kind of line is this? Non-proportional. Because it did not go through the origin. Let's look at our other line. Everyone good so far? What's the difference between 5 and 40?
35.
Don't make catch answer to everything. What's the difference between 40 and 65?
25.
Let them give a chance to. Okay, what's the difference between 1 and 8?
7.
And 8 and 13?
15.
5. Okay, so I need the difference in y, right? So m is difference in y over difference in x. So I go for it. What's 7 over 35? What does that equal?
5.
That's very sad. 7 divided by 35. You can simplify it because 7 will go into both, won't it?
It's 1 over 5.
It's 1 over 5. Well, and if I do this one, where I've got 5 over 25, what does that equal? 1 over 5. So that is definitely the slope, right?
Yes.
So if I go x, I go back 5 to go to 0, right? If I go back 5 to 0, I want 1 over 5, right? Well, that was nice of 5. If I go from 1 and I subtract 1, what do I get?
0.
What kind of line is that? Proportional. I used regression. I could use several different tools, and we learned about a couple different ones. I could write out the equation, take the slope, and stick a pair of coordinates in it, and see what happened with b. If b became 0, then I know it's proportional, right? Any questions on all these? Kind of using the same tools. You're getting a little harder because you got to recognize them. This is what I don't want you to do. I don't want you to get the paper and just look and quickly write proportional. I want you to kind of give proof to your statement. Does that make sense? The worst thing you do is write no, yes, no, yes, no, yes, and turn it in, and then when you get it back, just change it and go the opposite way. I don't want that. So I want you to show me and prove to me why you think it's proportional or non-proportional. Yay.
Bye.